Hello, my name is Christian Williams. This is my Circ 12A attempt. The date is December 5th of 2021. In the previous two attempts in B and C, we were using a RGB LED in addition to a bunch of Boolean values in order to get specific lights. So you could get pink or yellow just using red, green, and blue. In this attempt, I want to be able to directly control each of those values of red, green, and blue using potentiometers. So what we are doing, so in order to do that, we have to get kind of move away from the Boolean values and go back to more of an analog function on our board. So just to get straight back into the values here, we are going to be using a total of 9 values in here. We have 6 constant integers, 3 of which are for our RGB LED pins. So we are using 9, 10, 11, which, if you remember, they have to be 9, 10, 11 because they use pulse width modulation, which we need in order to set an analog value as opposed to a digital on-off. We are using 3 potentiometers in this project. So these constant integers are for A2, A0, and A1. The reason why 2, 0, and 1, as opposed to having 1, 2, and 3, or 0, 1, and 2 are here, is because it turns out that the RGB LED that I am using, the green and blue pins are swapped. So in order to make sense of a RGB, I have to have the blue pin set to 0 and the green pin to A1. And then you'll be able to see that in my in the wiring here in a moment. And then we are going to have 3 different values that we'll use in later on in the program for red, blue, and green. This is where we will be storing the value that our potentiometers will record. So in setup, you're probably familiar with this part. We are setting our pins to input and output. In this case, we have 3 pins that are controlling the RGB LED. So we are setting those to output, and then we have 3 potentiometers, so we are defining those as our input. We also have a little bit of a boot up sequence, just to make sure, so we can see that the RGB LED is working correctly. You'll be able to see that when we move to the actual wiring. Then the loop is actually pretty concise and pretty simple. First, we are setting our red, blue, and green values. So we will read the analog value of each potentiometer. We are going to map those readings to 0 to 255 instead of 0 to 1023. The reason for that is the LEDs only accept values from 0 to 255, but our potentiometers can take a value of can go all the way up to 1023. So we have mapped red, blue, and green associated, and then once it's done mapping, it will then write each pin with the new value red from here. So the analog write, the red pin will be changed to red, which is the analog reading of the red potentiometer, and so on. So code is very, very concise. Well, aside for the boot up sequence, of course. All right, now that the program's out of the way, we're going to move to the actual wiring. So this is the wiring here. This is the RGB LED right here, along with the 3 resistors. We are still plugged into 9, 10, 11 for our pulse width modulation. Then you can see we have our 3 potentiometers right here, plugged into ground and positive over here. We have these 3 red cords just to get power over to the 2 channels over here, since the potentiometers are going to be bridging the gap in this. And then to give myself a little indication of how much red, green, and blue are in each, I've just installed these little LEDs right here so we know which potentiometer is which, along with a little resistor on here. So because the power is going through the potentiometer to get to those LEDs, they will stay off until we twist the potentiometer, and then you'll see them slowly bright up. And then you can see with the potentiometers as well, the green wires are in A0, A1, and A2. So it is currently running, but in order to see the boot up sequence here, I'm just going to hit the reset button. All right, so it is now ready to go. So what that boot up sequence did was it just tested each of the 3 LEDs, so red, green, and blue, and then it turned all of them on for about 2 seconds. Having all of them on is the equivalent of white in our visual color spectrum, at least based off of what humans can see. So it is now ready. So by twisting each of these potentiometers, you can start adding blue, green, or red to it. So if I twist the blue, start twisting it, you can see it's very, very sensitive. I can twist, so that is now blue. I can turn that off, and it is now green, and it is now red. Now, if I wanted to mix, if I want to do blue and green, I can get cyan. I mentioned before that the green LED in here seems to be very, very dim in comparison to the others, so you have to be kind of very careful with how much blue, otherwise you're going to kind of overwhelm it. If we wanted to do magenta, we can move the red and the blue together, and then if we wanted white, we can just turn on all of them together, and we kind of get white. So using this, red and green is yellow, by the way. So just using these three potentiometers together, we can get, in theory, any color of light in the visual light spectrum that humans can see. That being said, I'm sure there's some colors that this thing can't really generate. So, all right, so there we go. I now have a controllable RGB LED using this coding here. Thank you for watching.